Hello YouTube. So it's been a while since I used this scope and I haven't used it very much, so I'm not super familiar with its functionality yet and how everything all works, but it took me a little bit to get it set up for the first motor, and now I'm there. So anyway, this is a 50mm stator HLD inrunner wired Y, and I have my DeWalt cordless drill on the motor shaft. The transmission is set to medium, and I'm just going to squeeze the throttle to maximum. On one of the phases, I've got the ground alligator clip, and I'm going to check the back EMF signal across the other two phases with the probe lead. The end of the probe lead, so it's set to 1x by the way. The end of the probe lead, because it has a ground plane on there, I've taped over that so that I can't accidentally short inside the connectors or whatever when I'm testing. So anyway, that is my setup, and we're going to look on the oscilloscope what we get out of this motor. So I've heard that these motors produce a fairly trapezoidal waveform on the back EMF, and we're about to see for ourselves what that turns out to be. Okay, so the first thing I want to point out is I've got the scope set to 5 volts per division. So that was basically 1, 2, 3, 4. So I was seeing 40 volts maximum and 40 volts minimum. So, 80 volts from the bottom to the top, doing that test at whatever RPM I was. And down here in the lower right hand corner, it tells me the frequency of the signal, which is said was 81 hertz. As you can see, that was not exactly a sine wave, but it sort of kind of was. Now we'll try the other phase. So that was the yellow phase connection. Now here's the blue. Yeah, that looks pretty much the same. And again, it said 81 hertz. So that is this HLD 50mm inrunner wired Y. Let's try the 25mm HLD inrunner wired Y on the next video.